this video we would be discussing about the energy. So work and power you know already. So first of all, see this example. We will learn from this example. Suppose there is a spring mass system here and we pull this object towards the right. So it means that we are working on it. So we are doing some work. Work SI unit is joules. When we do some work, it becomes here. Okay, it moved to here. Now if I will leave this, it will go back here and then it will come back here. So it will start oscillating like this. It means the work that I have done has what? Has put some energy into the object. So my work has been transferred as an energy in the object. So whatever I have worked, so this work will be equal to the energy that has taken by the object. So this concept or energy stored is the right word, stored. So whatever the work that I have done has been stored in the object. Like suppose there is some bow, the arrow, what we say, like if we pull it and then it goes like, so first we stretch it, we put some work, we do work, and then that work is stored as an energy in that arrow. Okay, leave this example, not a good example for that. Let's move further. Okay, in our syllabus we would be dealing with potential energy, kinetic energy. For that we always say that there is an object here, this is the height, this is the mass m, and gravitation is g. So this object has mgh potential energy. So this potential energy will got convert to kinetic energy when we will leave this object. So this object will go down. So the kinetic energy will convert to the potential energy will convert to kinetic energy. This is one concept. Second concept is, so this concept will be only used when it is conservative energies. We call it conservative because we are not putting any things to change the energy. It is by the field force. We can say that whatever the mechanism happening is by the field force. Field force is the gravitational force. So another concept is there. Suppose there is some rocket and it needs to go and we put some force over there, or there is some object and we are putting some force, so, or there is some hill, we are putting some force. So when we will put some force, so the total energy is not constant. Here the total energy is constant. So this was one case, this was the second case. In this case we will say that total energy here at the first and total energy at the second, the differences between them will be the work. So in the starting case, like the total energy for the first one will be potential energy 1 plus kinetic energy 1, and for total energy second will be potential energy 2 plus kinetic energy 2. So when we will have the difference of total energy, this will be equals to the work done. That's it. This is the concept. This concept will be used everywhere, whether it is a spring mass system. So in the spring mass system, there could be example like this. Like suppose this is the mean, so from x1 to x2 the object has been moved from x1 to x2. So in these types of cases there will be graphical questions. So work will be fs cos theta will be 0, so work will be fs, and the force on this will be minus kx from the Hooke's law. So in this case there will be fx, and if suppose, so this will be from x1 to x2. So there would be question like from x1 to x2 the object is moving, so this will be the work done, and this will be the energy stored. So this is the basic concept in this question. There is nothing much, because work, energy and power, they all are very interconnected topics. So the basic that you need to remember is there is two types of cases: conservative, when the total energy is constant. In this, potential energy will be converting to kinetic, kinetic will be converting to potential. And then there will be a second where the total energy wouldn't be constant. In that case, the change in the energy will be the work done by some body, like from by us also, from someone another also. That's it. There is nothing much more over this. So work, energy, power. So in this video we have discussed energy. Energy has been completed according to our syllabus. So thank you for being here. If you still have some doubt, just put it into the comment section.